Hello everyone. So welcome you all. So in this video, we are going to see with an example how to insert a node in a B tree. I believe that you have already gone through the previous lectures of B tree where we have discussed that what is B tree, how to insert a node in the B tree. So we have discussed that critical understanding we have already made. We have also discussed the requirement which is to be maintained when we are inserting a node in a B tree. Now this video is basically as an example of what we have discussed earlier. So let's start. So in this video, we are going to learn how we are going to construct a B tree. So B tree, we know, is an MV search tree of a defined order and it's a balanced tree. So we are going to insert these nodes. So let's start. For means every node of this B tree can take three key values and can have four child links. This is the meaning of order four. So we can insert. So first we insert two, and this is also our order tree. So the values are maintained in such a way that the lesser values kept at the left side and the larger values kept at the right side. So we insert 2, then we insert 6 because every node can contain a maximum 3 keys. So this is a kind of node, you can say. So it has only one key. So we can still insert more keys here. So then we insert 6. This is okay. And then we insert 10. So 2, 6, 10 is already been inserted. Now we are going to insert 20. So let's see how it is going to work. So let's say I'll do it like this. So we have inserted 2, then we inserted 6, and then 10, and then we inserted 20. Now this is going to violate our property of order 4 because order 4 says that maximum 3 keys can be placed at any node. So when we find that the node is already been filled with the required number of keys, and if other key need to be inserted, then we are going to split this node, and we are splitting from the mid value. So out of four, the mid value is this and this. So we are actually, so in this case, we are working with left biased. So if we have two mid values, we will take the left one, or you can take the right one. It does not make any difference. So, but we have to stick to one rule. So in our uh, working, we are sticking with the left. So whenever we have two median values, we will take the left value. So it is going to split. So 6 is going to split and it will bring like this. So we have 2 and then we have 10, 20. So tree is going to split like this. Okay. Then, so 2 is done, 6 is done, 10 is done, 20 is done, then 78. So 78 is start from the root and then we find that 78 should be inserted here. So every node that we are inserting, every key that we are inserting, every value that we are inserting must be inserted at the leaf. This is the property we know. Then 78 is done, then 5. So 5 is going to insert here because every node can have maximum 3 values. So still this is 2 values. So there is no issues. Then 90. Now, the moment you insert 90 here, you will find that it is having four key values, which is not fulfilling the requirement of order 4 tree. So here you will find the mid value. So we'll go with 20. So 20 will go to the parent, and so actually it will split into two parts. So this is one part, and this is the other part. So you can see the new tree that we get will look like this: 6. Here we have 2, 5, and here we have 20 is there, and here we have 10, and here we have 78, 90. So 90 is done. Then we have 25. So 25 is to be inserted here. And then we have 4. So 4 is going to be inserted here, somewhere here in between 2, 4, and 5. So let me write it like this. 4 is done. Then 80. So 80 comes out to be inserted at this place here. So let's say this is 80 I inserted here. So let me write it like this. This is going to happen now. Now this will violate the requirement. So we need to split this node. So now 70 is going to merge with the parent and it splits in two parts. So the resultant tree that we get is 6. This is 2, 4, 5. Then we have 10 here. Then we have 20 here. And then we have 25 here. We have 78 and 80, 90. This is how the tree will be look like after inserting this 80. Then 85. So 85 is going to be inserted here. So let us insert here 85. And then the last to be inserted is 82. So when you insert 82, 82 should be actually inserted here. So let me make some space for 82. So it will look like 82, 85, 90. Now again, this is something which is violating the order for requirement. So we are going to split this into two parts. But here we have to observe when it goes here, means if 82 goes here, then let's say this 82 moves here, then this parent will be having four key values, which is again not fulfilling the requirement. So what we can do is, again, this is to be splitted. So it will again split into two parts. So this is going to, so we'll find the mid value. This is the mid. So we'll split into this part. We'll get like this. 20 will go and become the root. Then we have 6 here. Then at the left we have 2, 4, and 5. And here we have 10. And here we have 78, 82. And at the left of 78, 82, we have 25. And at the right of this, we have 85, 90. So this is the final tree that we get after inserting all the nodes in a B tree of order 4. So you can see these are the nodes and they fulfill all the requirement of B tree. It is also balanced. Also we have 80 here. So you can see this is the tree that we finally get 26, 22, 4, 5, 10, 26, 2, 4, 5, and then we have a 10 here. 78 having a left child is 25, and then we have 80 is here, and 85 and 90. Or just have a look, like let me clean all this thing. So these are the stages that we have been through construct. So we insert 2, 6, 10, and then 20. So you can see this all steps we have been through, and this is the final tree that we get after inserting all these nodes. Okay, so let's take one more example of inserting the nodes in a B tree. So let's take a new example. This is the keys to be inserted in a B tree of order 3. So order 3 means that every node can have maximum 2 keys and can have 3 childs, or you can say that the 3 links can have. So we insert 12, then we insert 16. This is to done. Then we insert 16 because each node can have a maximum 2 keys. So this is okay. Then we insert 10. So 10 is going to be inserted here. So when you insert 10 here, now this node will have 3 keys, which is not possible because maximum 2 keys are possible. So we are going to split this from the median value. This is 12. So 12 is going to split like this. We have this structure. So 12 is inserted, 16 is done, 10 is done, then 20. So 20 is going to be inserted in this node. Okay. Then 78 is going to be inserted here. Now this is going to violate the requirement. So we are going to split from 20. So what we get something like this. 12. Here we have 10. Here we have 16, then 20, and then 78. Okay. So we are done. Then 20 is done. 78 is done. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 keys have been inserted. Then 15. 15 is going to be inserted here. and then 90 is going to be inserted here, then 25 is going to be inserted here. So when 25 is going to be inserted here, now this will violate the requirement. So we need to split this, and when split, the 78 will go up. But as we move the 78 to the parent will again does not fulfill the requirement. So have a look here. So if we go to scenario when 78 goes to the parent node, so we have 12, we have 10, we have 15, 16, we have 20 here, and then we have 25 and 78, let's say, goes up, and then we have 90. So if we have this kind of structure, then this is not going to, fulfill the requirement of order tree. So again, we are going to split this node 20. So finally, we are going to get this 20. We get this 12 here, and at the left of 12 is 10, and then we have 15, 16 here, and here we get 78. At the left of 78, we have 25, and the right of this is 90. So we are done with 25. Now next is 14. So 14 is going to be inserted here. So this will violate. So 15 is going to, with the parent. So what we get? We get 20, we get 12, we get 10, and then 15 is going to up 15, 14, 16, and here we have 78, 25, and 90. Okay, so far we are done with up to 14 and 80. So 80 is going to be inserted here, which will does not make any change, means there is no splitting is required. And then we are doing 85. So moment you do 85, 85 is to be inserted here. So let us make some space to write 85 here. When we write 85 and then 90, so 85 is to be splitted, means it should go and merge with its parent. So finally what we get something like this, 20, this is 12, 10, here we have 14, 15, 16, and then we have 78, here we have 25, and 85 is going to merge here, and here we have 80 and 90. Then the last we have is 82. So 82 is going to come here. So the tree that we get is this is our going to become a root node, and this becomes the internal node, this becomes internal node, these are the leaf nodes. So this is what we get finally. So let us clean this area. Just have a look to all the steps that we have gone through in a very clearly graphical format. Let me show to you. So this is the final tree that we are getting. So this is 20 will at the root, and then we have 12, 15 will be the internal node, 78, 85, and then we have something like this structure. So this is how we are inserting the nodes in a B tree of the given order. Now in the next video, we are going to see some example of building a node in the B tree. So this is all for this video. Thank you very much.